Good morning, students. Thank you very much, students, for clicking on my video. I'm your Nagini ma'am, chemistry mentor. In today's section, I'm going to discuss about the numericals in chemical kinetics, students. In this section, I'm going to solving some important questions, previous year's questions, students. Okay, and important formulas. That all I'm going to discuss now. Okay, so in this video, students, important formulas. These are the rate constant units of rate constant, and what are the units of zero order reaction, units of first order reaction rate constant. Okay, now so these are the units of zero order rate constant, first order rate constant, second order rate constant, students. Units. Okay, now how to find it? Nothing is there, students. Zero order reaction is nothing but n equal to 0. First order is nothing but order value n is equal to 1. For second order, n equal to 2. Okay, now just you substitute in this one in the units of rate constant, then you will get the units of zero order, first order and second order, students. And what are the important formulas? See here, T half is equal to 0.693 by K. This is rate constant. This is logarithm of K2 by K1 is equal to, and T half is directly proportional to 1 by a to the power of n minus 1. These are the important formulas, students. Once practice this formula, students. So based on these formulas, now I'm going to discuss the problems. And here first problem, see, the rate constant of a first order reaction is this one. Calculate its half-life period. So half-life period, how to find it? So T half is equal to formula 0.693 by K. Are you clear? So that formula you have to use, just substitute K value, then you will get the T half value. So till here in the previous video, students, I discussed you. Okay, what are the units of rate constant for zero order, first order, second order, and next what are the important formulas, and how to find the half life period if rate constant value given, how to find its half life period. Okay, so that all formulas and units. Next problem I discussed you, students, in the last video. Once you go through that video, students, now I'm not going to discuss about this one. And from the third formula, I'm going to discuss the problem, students. This one from here, second formula I discussed you this problem. Okay, now from third formula I'm going to continue this video, students. Because of some technical problems, that video is stopped nana till there only, so that's why I'm continuing that one video. Okay, thank you, students, please cooperate. Now see, students, here second question nana. 75% of the first order reaction is completed in 30 minutes. Calculate the rate constant of the reaction. So 75% of the first order reaction completed in 30 minutes, it seems. Calculate the rate constant of the reaction. So how to find a rate constant value? What is the formula here? What you have to use? This formula you should use. K is equal to solution. K is equal to 2.303 by T into logarithm of a by a minus x. Are you clear this one? So this formula we should use, Nana. This is initial concentration of the reactant. This is the final concentration of the reactant, students. Okay, na? Or we can use another formula also. So that is K is equal to 2.303 by T into logarithm of R naught by R. This also we can use. This is the 0 indicates initial, square bracket indicates concentration, reactants. It is the initial concentration of the reactant. This is the final concentration of the reactant, students. Okay, Nama. So by using this formula, we have to find the rate constant of the reaction. Rate constant is nothing but K value. We have to find the rate constant value, students. Okay, ma. So K value we should find. Now see, students, the reaction, first order reaction, it is completed. We know that this is the first order reaction, correct? The rate constant equation. And next 75% of the first order reaction is completed in 30 minutes. That means time value 30 minutes given, and it is completed 75% of the reaction, students. For example, see here, reactants gives products, nana. Here reactant is, suppose initial it is 100%, but product initially 0. Okay, now product is 0, students. Initially reactant is present 100%, but product initially is 0 nana. So this is initial concentration. How much completed, students? 75% of the reaction completed. That means 75% of the product is formed here. Are you clear? This one, product is formed. That is the meaning. 75% of the first order reaction is completed. That means 75% of the product is formed. That means reactant, 100% reactant is converted into 75%. Are you following? So that means 75% of the product is formed. That means how much reactant is decreased, students? Because the reactant concentration is decreases, product concentration increases. So it is 0 to 75% increases. This reactant concentration how much decreased, students? So that's how, what you have to do, minus 75. Do 100 minus 75, you will get how much, nana? 25% you will get. Are you clear this one? Understanding? So that means it is the R value, final concentration. Initial concentration how much, students? It is the initial concentration 100%, final concentration is 25%. Are you clear this one? So that's why here R naught value how much, nana? R naught value is equal to 100, R value is equal to 25. Clear this one? R value how much? 25 you have to take. Clear? Initial concentration 100%, initially product is 0, so that's why it is hard to take 0. After some time what will happen? Product is 75%, the reaction 75% completed means 75% of product is formed. That means how much reactant is decreased, students? From 100 to 75 means 25% of the reactant is still left. Are you following? So this much is there still. So 25% of the reactant is left. This is the final concentration of the reactant. This is the initial concentration of the reactant. Okay, so just you, nothing is there, students. 75% kada, 75% cent is nothing but 100, that is the initial, and 75 is the final final concentration is nothing but 100 minus 75 you have to do, then R value will get. Are you clear this one? So this is the final concentration. Clear, nana? So like this you have to find it. So understood, amma? 75% is nothing but R naught value how much? 100 you have to take, because percent, that's why I am taking as 100. And next one, R value final concentration, just you have to do subtraction 100 minus 75, then you will get the 25. This is the final concentration. Clear this one? So just these values here substitute. Okay, now see, students, here K is equal to 2.303 by T value, time how much given? 30 minutes given, into logarithm of initial concentration by final concentration. Initial concentration is how much, nana? 100, and final concentration is how much? 25. So 100 minus 100 by 25. Clear this one? 100 by 25. 25 in 100 how many times, students? 4 times will get cancelled. So K is equal to 2.303 by 30 into logarithm of 4. This log 4, how to write it, students? K is equal to 2.303 by 30 into logarithm of 4 value. Log 40 under 0 you have to see, nana. Understanding? So otherwise you can write it as log 2 square. 4 we can write it as 2 square. Understanding? 2 square. So that means here log a to the power of n formula, what, students? Logarithm of a to the power of n is equal to n into log a. Correct? So this is the formula, students. Use this formula here. Log 2 square is nothing but 2 log 2. Clear? So then what you will get, nana? See here, what you will get? K is equal to 2.303 by 30 into 2 into log 2. Correct? 2.303 by 30 into 2 into log 2 value 0.3010. Correct? Now value calculate, students. You will get the answer. See, nana, value 2.303 into this value 0.6020. Correct? 0 into 0.6020, right, divided by 30. How much, nana? 0.0462. Correct? So answer is 0.0462. answer you will get. Okay, so what are the units, students? Here what are the units given? Here time units, minutes given. This is concentration, this is concentration. Both units will get cancelled. Moles per liter cancel. This is in the denominator minute. If it is coming to the numerator, what is the unit, students? That is minute inverse. Are you clear? So this is the problem, students. Like this you have to find out. Understanding. If suppose these students 80% completed. Suppose the reaction 80% completed. 80% completed means how to write, students? See, tell me once. 80% completed reaction. That means what is R naught value, Nana? 100 per cent kada. So cent is nothing but 100. R value how much? 100 minus 80. So then how much you will get? 100 minus 80 is nothing but 20. This is R value. So how much percentage given? Like that you have to calculate, students. Okay, Nama? Now see, students, next problem. Show that for a first order reaction, T 87.5% is equal to 3 into 50% is given. So first we have to find T 87.5% value, we have to find it. And after that T 50% for first order reaction, we know that T 50% is nothing but T half. For first order reaction 0.693 by K. Correct, Amma? So for first order reaction, so that's say first I am going to calculate T 87.5. So same formula we should use, students. Here also K is equal, this formula you have to take, and in the place of T, how much you have to find? T 87.5 you have to calculate, right? Now see, Nana, T 87.5. So that means T 87.5% is equal to how much, Nana? What you have to write formula? 2.303 by K into logarithm of R naught by R. Initial concentration by final concentration. Clear this one? Initial by final concentration. Now 87.5% is given. So that means R naught value, tell me, students, how much we have to take? 100. R value how much, students? 100 minus 87.5. 100 minus 87.5 how much, Nana? 100 minus 87.5. Okay, 87.5, 12.5. So this is R value, students. This is the concentration of the reactant. Okay, this is R naught, this is R value. So these two values here substitute in the formula, then you will get T 87.5%. This value don't change here. K value not given in the question. We have to show that this is equal to 3 times of T 50%. Okay, just as it is, you keep, Nana, into logarithm of R naught value how much? 100. R value is 12.5. Clear? Okay, so T 87.5% is equal to 2.303 by K into logarithm of 100 by 12.5. How much, Nana? 100 divided by 12.5. How much, students? 8 answer. Okay, so log 8 will get answer. Understanding, students? Log 8. Okay, Nama. So this is T 87.5 value, log 8. So what is the log 8 value, students? Log 80 under 0 you have to see. Okay, now once how to see logarithm values also in the previous videos I kept, Nana. Once you go through that, how to see log 8 is nothing but 80 under 0 you have to see. This value is 0.9030. How much, Nana? T 87.5 value. T 87.5 value 2.303 by K into log 8 value 0.9030. Okay, once you check, students, log 8 value is nothing but 80 under 0 you have to see. Okay, 0.9030 you will get. Okay, this is T 87.5. What about T 50%? T 50% is nothing but we can write it as T half. Correct? It is equal to, for first order reaction formula, 0.693 by K. Correct? This is the equation number 1. This is the equation number 2. We have to find equation 1 by equation 2. Okay, you have to calculate equation 1 by equation 2. Calculate, Nana. Equation 1 is 87.5 LHS part, and here LHS part equation 2 T 50% is equal to RHS part is which one? By K into 0.9030 divided by how much, students? T half. This is 0.693 by K. Correct? 0.693 by K. Then what you will get? T 87.5 by T 50% is equal to KK will get cancelled. Correct? Then value how much? 2.303 into 0.9030 by 0.693 you will get. Understanding? So this value how much we have to calculate? 2.303 into 0.9030 divided by 0.693. How much, Nana? 3. How much answer you got? 3 students. Clear this one. So 3. So value is 3. So that means what we can write? T 87.5% is equal to what we can write? Is equal to this is value is 3. 3 into this one, T 50 percentage. Clear this one? This only question. Understanding, Amma? Show that for your first order reaction. So here T 50% directly you have to take Nana this formula. Okay, because we know that T half value is T half for first order reaction is 0.693 by K. Okay, na? In the place of T half, if suppose they given any another for any another percentage, then you have to calculate that also based on this, like this only have to calculate, students, this also. Okay, Nama? This is a third model, students. Now coming to the fourth model problem. See here. Show that for a first order reaction, T 99.9% is equal to 10 into T half. Same model problem, students. Here also you have to find T 99.9%. What is the formula, students? K is equal to formula what? 2.303 by T. Solution by T into logarithm of R naught by R. Correct? So R naught, we have to find T value. So that's a T 99.9% is equal to 2.303 by K into logarithm of R naught by RM. Okay. So T 99.9% is equal to 2.303 by K into logarithm of initial concentration. How much? T 99.9. T 99.9% means R value, R naught value 100%. So 100, R is equal to how much? 100 minus 99.9. How much you will get, students? 0.1. Correct? 100 minus 99.9. Okay. Once we'll check, students. 100 minus 0.99.9. 0.1, correct. So 0.1 you will get. This is R value. Now here substitute in the place of R naught and R. R naught is 100 by 0.1. Understanding? So T 99.9% is equal to 2.303 by K into logarithm of this value 1 by 10. 0.1 we can write it as 1 by 10. 10 it will go to the numerator. 100 into 10, 1000. Are you clear? This is 1000. Then how much you will get, students? T 99.9% is equal to 2.303 by K logarithm of 10 cube we can write. Correct? 1000 we can write it as 10 cube. Okay, 10 cube is nothing but again we know that one formula, logarithm of a power n is equal to n into log a. Correct? So use this formula. So logarithm of 10 power 3 is nothing but 3 into log 10. So that's why T 99.9% is equal to 2.303 by K into 3 log 10. Log 10 value how much, students? 1 only. Clear? Log 10 under 0 you have to see, you will get into 3 answer. So this is the equation number 1. Now another, here we have to show T half. Another one is T half. So what is the T half, students? Formula T half is equal to, for first order, 0.693 by K. This is the second formula, second equation. Now equation 2 by equation 1 calculate. Okay, equation 2 how much, Nana? T 99.9% by here LHS part in the second equation, T half is equal to how much, then RHS part 2.30 into 3 by K. T half, this value 0.693 by K. Correct? 0.693 by K. This one will get cancelled. T 99.9% by T half is equal to this value how much, Nana? 2.303 into 3 by, okay, 0.693. Clear? So how much you will get, students? This value 2.303 into 3 divided by 0.693. Okay, then you will get 9.96. This answer is 9.969. You got 9.9 is nothing but we can write it as nearly it is equal to 10. Correct? It is equal to 10. So that's a finally what we can write, students. T 99.9 percentage is equal to 10 into T half. Clear? So this is the relation between T 99.9 percentage is equal to 10 into T half, students. Clear? This value we got, it is nearly equal to 10, so that's why this value we wrote. That only question, na, T 99% is equal to 10 into T half. Okay, we showed that one. Now see, students, last model. No, we have one more model is there. Now see, the rate constant of a reaction is double when the temperature is increased from 400 Kelvin to 410 Kelvin. Calculate the activation energy is asking Nana. Calculate the activation energy. What is the formula, students? Here you have to find the activation energy. So you remember this one, activation energy you have to find it means formula is logarithm of K2 by K1 is equal to formula here I discussed you. EA by 2.303 into R T2 minus T1 by T1 T2. Correct? This formula we have to use, Nana. Understanding, students? See here. Formula is, what is the formula? Logarithm of K2 by K1. Correct? K2 by K1 is equal to K2 by K1 is equal to formula EA by 2.303 into R into T2 minus T1 by T1 T2. So this is the formula, students. Now see, Nana, what given here? K2 by K1 value how much given? Rate constant of a reaction is doubled given. Doubled means K2 by K1 value 2, Nana. So that means log 2 is equal to activation energy only we should find EA by 2.303 into 2.303 into R value. What is R value, students? 8.314. How much, Nana? R value 8.314. T2 minus T1. What is initial and final temperature, students? This is T1, this is T2. T2 minus T1 is nothing but 410 minus 400 by 410 into 400. Okay, then you like this you have to find it. Now see, students, log 2 is equal to EA by 2.303 into 8.314. 410 minus 400 is nothing but 10 by 410 into 400. Clear? So this value how much, Nana? Log 2 value how much? 0.3010. Okay, EA by 2.303 into 8.314 into 10 by 41 fours are how much, students? 164. Remaining 3 zeros are there. Like this you have to take. Now EA value we should find, students. How to find the EA value, Nana? EA is equal to how much you will get? 0.3010 into 2.303 into 8.314 into 164,000 by 10, Nana. You have to find this value. So this 0 will get cancelled. Correct? So what you will get answer, students? So just multiply this all. 0.3010 into 3010 into 2.303 into 8.314 into 164 two zeros. Clear? So how much you got? 94,517. How much, Nana? 94. EA value how much we got? 94,517.95 answer we got. Understanding? So this is the activation energy, students. Are you clear this one? So this is the activation energy value is 517.95. Are you clear? This is in the joules, students. In kilojoules is nothing but you have to divide with 1000 students, and what you will get, Nana? 94.517. So answer we can write it is in kilojoules, 94.5179. This is the answer, okay, now in kilojoules. Understanding, students? So like this you have to find the activation energy. Clear this one? We have to find the activation energy by using this question. Understood, Amma? So last problem, see students, what here given. If half-life period of a reaction is inversely proportional to the initial concentration of reactant, what is the order of the reaction is asking, students. What is the order of the reaction? Okay, now if half-life period of a reaction is inversely proportional to the initial concentration of the reactant, what is the order of the reaction? So you have to, what formula you have to take here? Last formula you have to take. T half is directly proportional to 1 by a to the power of n minus 1 you have to take. Here asking order, students, order of the reaction is asking. If suppose I am taking n is equal to 2, I am taking nana. Here substitute, then you will get T half is equal to T half directly proportional to 1 by a to the power of 2 minus 1. Then how much you will get? T half is directly proportional to 1 by a. That is nothing but T half is, that is half-life period of a reaction is inversely proportional to the initial concentration. Yes, it is the initial concentration of the reactant. Then what is the order, students? If n equal to 2, then we will get this relation. So that's why order is equal to how much, students? Order is 2. Understanding? So like this you have to calculate, students. Okay, I hope you like this video, students. If you like this video, please like, share, comment and subscribe my channel, students. Okay, thank you very much, students.